a cylindrical pie tin is h centimeters high with a diameter, the volume of the pie tin is 1000 centimeter cube, show that the surface area of the open tin is given by A equals pi d squared over 4 plus 4000 over d, and find the minimum surface area. You can see that's the cylindrical pie tin. This is a diagram to show an example of a cylindrical pie tin. So we've got a cylinder here. So that's the cylinder, and that's the base of the cylinder. So this is open. So what is the circumference of a circle here? We know what that circumference is. Think about that for a minute. And if you open the cylinder, if you break it into two, you get the base area and the hollow height of a circle. Now, a few things we need to ask ourselves. If we open that, we get a rectangle. So you can see that length from there to there is the circumference of a circle. So that's the circumference of a circle, and it forms a rectangle. And you can see the height here. So we've got the height here, and the length here is the circumference. The area of this rectangle is going to be, the circumference of a circle is 2 pi r, or you might say pi d, because 2r equals d. So d equals 2r. So the area will be pi d h. So that will be the area, pi d h. So that's the area of that one. And the area of the base will be pi r squared, because it's a circular base. And we know that r is d over 2. And if you square r, you have to square that one. And that will be d squared over 2 squared, 4. So if you replace r squared with d squared over 4, the area of the circle is pi d squared over 4, or you might say pi r squared. So those are the things we're going to use in this calculation. So we know the surface area, S for surface area, is going to be the area of the base, which is pi d squared over 4, plus the area of the rectangle when you open it up, and that is pi dh. We also know that we're given the volume. So the volume is going to be the surface area of the base times the height. That's how you work out the volume. So volume, V, equals the surface area, which is pi d squared over 4. So that's the base area, times h. So that's the volume, and that equals 1000. Pi d squared h equals 4000. And we need to divide both sides by pi d squared, right? H equals 4000 over pi d squared. So that's from the volume. Volume is going to be the area of the base, which is circular. That's the area of the base, times the height. So the area of the base is pi d squared over 4 times h. And then rearranging it, making h the subject, we got that. So what I'm going to do is place h into there. So the surface area, S, is pi d squared over 4 plus pi d, open bracket, the h is 4000 over pi d squared, close bracket. As you can see, the pi cancel pi, d cancel 1d, so you got 1 left. And now, to simplify that, the surface area S equals pi d squared over 4 plus 4,000 over d. And that is what is being required that we prove. Or you can call it A for area, but I'll just call it surface area S for, instead of saying A, I said S. It's the same thing. So the A, or if you like S, is pi d squared over 4 plus 4,000 over d. And the question then says, find the minimum surface area. Surface area is now a function of d. What that meant is S equals d to power of n. That's how we write it. If we're going to apply differentiation, S is a function of d, then we have to write the function in terms of S equals d to power of n. Therefore, we can apply derivative here. We can then say ds over the d obviously is the variable here, will be equal to n d to power n minus 1. And also, if we're going to find the second derivative, we can write the 2s over the d squared equals n into bracket n minus 1 d to power n minus 2. We need those two in order to show the minimum, to find the minimum surface area. If you're to find maximum or minimum, you have to use these two. Why? Because at the top of the maximum or the bottom of the minimum, you would have the S over the D, where that's the diameter somewhere, and that will be equal to 0. Because the gradient of a straight line is 0. If you then differentiate second time, second derivative, this is second derivative, that's first derivative. If that second derivative is positive, that meant the 2s over the d squared is greater than 0, positive. That is what we call minimum. So that means the curve is minimum. And it has a value of d there. That's what we're looking for, that value of d. If you differentiate again and it was negative, then d2s over dd squared will be less than 0. That's negative gradient, and that's positive gradient. And this will be maximum. You can see that's maximum and that's minimum. So that's why we need to find the S, the D, to make that equal to 0 and find the value of D at the minimum or maximum. We're just using second derivative to show that it is the minimum or maximum. So this will be max surface area. In that case, for the value of D, that means we get the value of D and we plug it back in here, we can get the surface area. Or this will be minimum surface area. Whatever that value of D is, we can plug it here and find the surface area. We need to do the first derivative, equate it to 0, and then find the value of D. Right, so in order to do that, we have to make sure the function is in that format. X equal to D to power of n. Is our function in that format? This is a function here. Just before we start, remember that 1 over D is equal to, in indices, D to power minus 1. That 1 is here. What about 1 over D squared? That will be D to power minus 2. Remember that power here, 2, is this 2 here. And the 1 here is this 1 here. And that's how we convert this. So that's how we're going to convert that into that to then look like that. So we need to then rearrange this function like that to look like that. So we're going to use s equals pi over 4 d squared. So that's okay because there are two terms here, 1 and 2, plus 4,000 times 1 over d. That's same thing as that. If you see the 1 over d here, we can write it like that. And so we can get s equals pi d squared over 4 plus 4,000 d to power minus 1. So now that looks like that. N is minus 1 here, n is 2 here. Now we can apply derivative. So ds dd will be equal to 2 times pi over 4 will be pi over 2, because 2 here, that 2 we cancel 4 here, and you're going to get 2 at the bottom. So that's pi over 2 d to power 2 minus 1, 2 minus 1, so that would be 1. Now this is minus 1 times 4,000, that would be minus 4,000 d to power minus 1 will be minus 2. And you can see d to power minus 2 is 1 over d squared. So that will be pi d over 2 minus 4,000 over d squared. And that has to be equal to 0 because that's where we are now. So that's the top of the hill there, or the bottom of the dip. So which is which? But we're going to find out. Now we need to solve this problem. So pi d over 2 minus 4,000 over d squared equal to 0. Multiply both sides by d squared to get rid of the denominator here. So that will be pi d cubed over 2. And then if I move the 4,000 to the other side, equals 4,000. Because that d squared, we cancel the d squared here. You just get 4,000. And move that to the other side, you get 4,000 there. Multiply both sides by 2 to get rid of the 2 here. You get pi d cubed equals 8,000. Therefore, d cubed equals 8,000 over pi. We need to cube root here because there's d cubed here. So we want to cube root. So d would be, well, if you cube root 8,000 over pi cube, well, if you cube root 8,000, you're going to get 20. Now we can work that out by using 2 to the power of 3 is 8. 8 equals 2 to the power of 3. 8,000 will be 20 to the power of 3. 20 times 20 times another 20, that will give you 8,000. So there's 3 20s we give you that. That's why 20 to the power 3. And if you then cube root that, so if you cube root 8,000, you have to cube root that. And what that meant is 20 to the power of 3 all to power 1/3. You can see the 3, we cancel 3 there. That's 20 to the power of 1, and that's 20, and that equals 20. And because now you have to cube root pi as well, so that will be cube root of pi. So that's what d is. Now find the second derivative, which means I need to differentiate that again. The 2s over d squared will be equal to, well, that's d to the power of 1. That means 1 times pi over 2 is pi over 2. Then d to the power 1 minus 1, because 1 minus 1, I'm just doing that again. So 1, or you can go straight from the S here, straight to this. You can go from there straight away to that, using that. But I'm just doing that again. So that would be as d to the power 0, because 1 minus 1 is 0. So that's 1. Now, so I've got minus 2 here, and minus 2 times minus 4,000 is minus 8,000. D to power minus, well, minus 2 minus 1 is minus 3. Anything to power 0 is 1. So d to power of 0 equals 1. So that's just pi over 2. Right? And we know that minus 2 times minus 4,000 is plus 8,000. So that's plus 8,000, not minus, because that's minus 2 times minus 4,000 is plus 8,000. And then d minus 2 minus 1 is minus 3. And that can be written as plus 8,000 over d cube. But we know what d is, right? D is 20 over cube root pi. That meant if you d squared s, d squared equals pi over 2 plus 8,000 over, well, so we need to cube that now. 20 over cube root pi. When you cube that, when you cube 20, remember 20 cube is 8,000. So you're going to get 8,000 here at the bottom. And that 8,000, we cancel the 8,000 on top. So that's gone. Then you're going to have 1 over, if you cube root pi, that will be pi to power 3 over 3. That will be pi to power of 1. So that would just be pi at the bottom. If you write 1 over pi, that will be pi. So basically, the whole thing here will become pi. Remember, 20 cube is 8,000. 20 cube is 8,000. So that's 8,000. That 8,000, we cancel the 20 cube. Then you're left with 1 over cube root pi. If you cube root, right, you're just going to get pi, which is 1 over pi. 1 over pi is pi. So the whole thing here is pi. Therefore, you're going to get 2 pi plus pi. So therefore, d squared s over d2 equals 3 pi over 2. So that shows it's positive. That is minimum, because d squared s over d squared greater than 0. That's a minimum. Yes, it is a minimum. Now, to find that value, the minimum surface area, we need to plug in the value of d. We've shown that d is minimum at that point. We now need to plug this value of d into the s equation, and then we find s. S will be equal to pi d squared, so that's 20 over cube root pi. So you square that, then you divide it by 4, so that's 4 there, dividing it by 4, plus 4,000 over 20 over cube root pi. Now, if you plug all that into your calculator, so make sure you do that properly. Okay, turn on the calculator, open bracket to start with, then do the fraction key. To get the pi, do shift, that one here, times 10 to the power x will give you the pi. Bring the arrow key down, put a 4 in there, move the arrow to the side, another open bracket, this time, fraction key, do 20, then move the arrow key down. You want cube root. You can see from there, shift that will give you cube root. So you do shift and you want to press that. And then you want to put inside there a pi, so you do shift and that again. You get a pi. Move the arrow key to the side there and close the bracket. But you want to square that, so you might just press a square here, that will do it. And then you do your plus key. Now you need another fraction key, 4,000, arrow key down, put another fraction key underneath that. You got 20, arrow key down. Again, you want cube root pi, so to get the cube root to that one here, shift cube root, so that's that one here. Now you want the pi, shift there, I give it a pi again, so that's good. Move the arrow key now to the side. Now the arrow key is on the side, we need to close that bracket here and press equal key. So now the answer we should be getting is 439, so S equals 439 to 3 significant figure. And that's the value, the minimum value of the surface area.